In this lesson, we are going to take a look at how to use quotient rule to find derivative of functions. We normally tend to use quotient rule whenever we have quotient of two functions. Now, if you take a look at the top right side of the screen, we have the formula. This basically says the derivative of the top function multiplied by the bottom function minus the top function multiplied by the derivative of the bottom function divided by the bottom function square. Let's take a look at some examples. So this is the first example. And let's say we have y is equal to 2 over s. So we want to use quotient rule to find the derivative of this function. So what we're going to do, this is going to be y prime of s, which is the derivative, is equals to. So it's going to be derivative of the top function. Derivative of 2 is 0 because derivative of constant is 0. So this is 0, then multiplied by v, which is the bottom function. This is s. Then minus u. U is the top function. So this is 2. Then multiplied by v prime, which is the derivative of the bottom function. Derivative of s is 1. So this is going to give us 1. Then divided by v square, which is the bottom function square. So this is going to be s square. So this is 0 multiplied s is 0. Then we are left with negative 2 because 0 minus 2 is going to give us negative 2. So this is negative 2 over s square. So this is the derivative using the quotient rule. So let's take a look at another example. Let's say we have y is equal to s plus 1 divided by s minus 1. So we want to use the quotient rule to find its derivative. So this is y prime of s is equal to. Now it is going to be the derivative of the top function. So derivative of s plus 1 is going to give us 1. Then multiplied by v, which is the bottom function. So this is s minus 1. Then minus u. What is u? U is the top function, which is s plus 1. So this is going to be s plus 1. Then multiplied by v prime, which is the derivative of the bottom function. So derivative of s minus 1 is going to give us 1. So this is multiplied by 1. So this is going to be divided by v square, which is s minus 1 square. So this is going to be s minus 1. I'm going to have s minus 1. Then if you take a look at the value inside this parenthesis, this is going to be s plus 1. Because we're having negative outside the parenthesis, we're going to distribute this negative inside the values. So we're going to distribute this negative inside this parenthesis. So this is going to be negative s, then negative 1, because negative is going to multiply everything inside the parenthesis. So this is going to be divided by s minus 1 square. As you can see, s is going to cancel s because s minus s is going to give us 0. Then negative 1 is going to give us negative 2. So this is negative 2 divided by s minus 1, then raised to the power 2. So this is going to be the final answer. So this is the derivative of the function. So let's take a look at another example. Let's say we have y is equal to e raised to the power of s plus 2, then divided by e raised to the power of s. Now we want to find the derivative of this function at s equal to 0. So we're going to use the quotient rule as well. So this is going to be y prime of s. This is equal to. So it's going to be the derivative of the top function. So what is the derivative of e raised to the power of s plus 2? Derivative of e raised to the power of s is always e raised to the power of s. So this is going to be e raised to the power of s. Derivative of 2 is 0 because 2 is a constant. So this is multiplied by v, which is the bottom function. So this is e raised to the power of s. Then minus, what is u? U is the top function, which is e raised to the power of s plus 2. Then multiplied by v prime, which is the derivative of the bottom function. Derivative of e raised to the power of s is also e raised to the power of s. So this is multiplied by e raised to the power of s. This is divided by v squared, which is e raised to the power of s squared. So this is e raised to the power of s squared. So e raised to the power of s multiply e raised to the power of s. This is going to give us e raised to the power of 2s. Now, if you take a look at the value inside this parenthesis, e raised to the power of s is going to multiply everything. So this is going to be negative. E raised to the power of s multiply e raised to the power of s is going to give us e raised to the power of 2s, then plus 2 e raised to the power of s. So this is divided by e raised to the power of s, then raised to the power of 2. Now we need to distribute this value. So we need to multiply everything inside this parenthesis with negative. So doing this, we're going to have e raised to the power of 2s, then minus e raised to the power of 2s. Then negative times positive is going to give us negative. So this is negative 2e raised to the power of s. Then divided by e raised to the power of e raised to the power of s raised to the power of 2 can also be written as e raised to the power of 2s. So this is going to be equal to, now, as you can see, e raised to the power of 2s is going to cancel out. So we are left with just negative 2 multiply e raised to the power of s, then divided by e raised to the power of 2s. So this is the derivative. This is y prime s. But because we also want to find this at s equal to 0, so what we need to do, we just need to replace s with 0. So this is going to be equal to negative 2 multiply e raised to the power of 0, then divided by e raised to the power of 2 multiply 0 is 0. So this is 0. So e raised to the power of 0 is going to be 1, because anything raised to the power of 0 is always 1. So this is negative 2 divided by e raised to the power of 0 is 1. So the final answer is going to be negative 2. So this is going to be the final answer. Now let's take a look at one more example. So let's say we have y is equals to 1 plus cosine s, then divided by sine s. We want to take the derivative of this function using the quotient rule. So this is going to be y prime of s is equal to, so it's going to be u prime, which is the derivative of 1 plus cosine s. Derivative of 1 plus cosine s, this is going to give us negative sine s, because the derivative of cosine s is negative sine s. Then we have to multiply this with v, which is the function or the value on the denominator. So this is going to be sine s. As you can see, the value on the denominator is sine s. So this is minus, what is u? U is 1 plus cosine s. So this is going to be 1 plus cosine s. Then multiplied by v prime, which is the derivative of the bottom function. Derivative of sine s is going to give us cosine s. So this is multiplied by cosine s. So we have to divide this with v square. So what is v square? V square is going to be sine s square. We can also write it as sine square s. So this is going to be equal to negative sine s multiply sine s is going to give us negative sine square s. Then minus cosine s is going to multiply everything inside this parenthesis. So doing this, we are going to have cosine s plus cosine s square. We can also write it as cos square s. So this is divided by sine square s. Now the next thing you want to do, we are now going to multiply this negative with the values inside this parenthesis. So we're going to multiply this negative with the values inside the parentheses. So this is going to be negative sine square s, then minus cosine s, then negative times positive is going to give us negative, so this is negative cosine s squared divided by sine s squared. Now, if you take a look at this, negative sine square s, negative cosine square s, we can write this as negative sine square s plus cosine square s is going to be the same value, and minus cosine s. Then this is divided by sine square s. So this is going to be equal to, we know that sine square s plus cosine square s is 1. So this is going to be negative 1, then minus cosine s. We know this using trigonometry identity. Sine square s plus cosine square s is equal to 1 using trigonometry identity. So this is divided by sine square s can also be written as 1 minus cosine square s. So this is 1 minus cosine square s. Using trigonometry identity as well, this is 1 minus cosine square s. Now on the numerator, negative 1 minus cosine s, this can also be written as negative 1, then multiplied by 1 plus cosine s, then divided by, also 1 minus cosine square s, this can also be written as 1 minus cosine s multiplied 1 plus cosine s, because 1 can also be written as 1 square. So if we have 1 square minus cosine square s, if we factor out this, we are going to have 1 minus cosine s, then multiplied by 1 plus cosine s. As you can see, 1 plus cosine s, they are going to cancel out. So we are left with negative 1 divide 1 minus cosine s. So this is going to be the answer. Or if you want to simplify this further, you can say this is, also write your answer like this. If you multiply the top and bottom with negative, this is going to be 1 over cosine s minus 1. You can also write your answer like this. Anyone is acceptable. So the derivative y prime s is equal to 1 over cosine s minus 1, or negative 1 over 1 minus cosine s.